our final way that we're going to solve polynomials is by using a graphing and polynomial division combination. Now, once again, we're going to introduce the idea of a prime polynomial as a polynomial that cannot be factored. And we need a few more definitions here. First is the remainder theorem. And the remainder theorem says that when you're dividing a polynomial, that means using long division, synthetic division, or box method, that when you have a factor that's given, then your remainder should be 0. So let's take a look here at this polynomial, and we're going to divide it by x minus 3. Now, I'm going to do synthetic division because that should always be your first go-to. It's quicker, and you can get through the problems much more efficiently. I'll also show you what it looks like for polydoku, and then I'm going to see what it looks like when I plug in just 3. So for synthetic division for x minus 3, I need to set that equal to 0 and solve. So I'll add 3 to both sides, and that gives me that x equals 3. That's what I'm going to start with my synthetic division on. I don't have any missing exponents, so I'll write my coefficients over here. Bring down the first one, and I have negative 3 times 3. Remember the mantra of synthetic division. Follow your mama. So multiply. Negative 3 times 3 gives me negative 9. Then add 5 and negative 9, and we get negative 4. Then we multiply this 3 times negative 4, and we get negative 12. And then we add, and we get negative 8. So if we had our depressed polynomial, which is another one of our definitions down here, we would have 1 less than the degree, so x, minus 4, and then this would be part of the remainder. This is an important part here. Let's take a look at what it looks like with polydoku. So we're dividing by x minus 3. So the first box goes negative 3x squared. What times x gives me negative 3x squared? Negative 3x. Negative 3x times negative 3 gives me positive 9x. 9x plus what gives me 5x? That's negative 4x. And then x times what gives me negative 4x? Negative 4. Negative 4 times negative 3 gives me positive 12. 12 plus what gives me 4? Negative 8. And that's my remainder here. So again, take a look at the fact that the remainders were the same. And now finally, here's where we're going to really make the connection. If I were to take and plug 3 into my equation here, negative 3 times 3 squared plus 5 times 3 plus 4. And type that into my calculator. Negative 3 squared, or sorry, negative 3 times 3 squared plus 5 times 3 plus 4. Take a look at what I get. Negative 8. That goes to talk about the remainder theorem here. That's also why if it is a factor, then we should be getting 0. There should be nothing left over when I'm dividing it out. Because remember, factors multiply together to equal our polynomials. So if we had remainders, we'd have an issue with things dividing out factors. All right, turn the page and take a look at our 4 examples here. Now the reason why it says using graphing and polynomial division is because it's not always going to be obvious what factor I need to plug in there. For example, in our previous example, we had just given x minus 3. Well, they didn't give us any factors here. They just said to solve, and to give exact, simplified answers, and we have to prove it with division. Well, in order to have something to actually divide, we're going to use our calculators and graph it and find one of the zeros. So your first step is to type this into your calculator and the y equals. So x to the third power minus 6x squared plus 11x minus 6. So I've typed that into my y equals, and then I'm going to take a look at what it looks like as a graph. So here's my graph. There's what I typed into my y equals. And when I look at this graph, I can see that there are 3 zeros here. So 3 zeros. That means that I need to find those zeros. But I want to focus my attention on any zeros that are nice, because there are some zeros that are going to be irrational numbers, decimals that continue on forever, and I can't use those with polynomial division. I want to find only nice rational zeros, preferably one that ends on an integer, a nice pretty number. So it looks like we're in luck here that all 3 of our zeros are nice pretty numbers, but we'll double check as soon as we find one. We're good to go. So second calc 0, left side, the right side just a little bit above, and one of my zeros is at 1. That's all I need. So we got 1 from a graph. We're going to use synthetic division, or like I showed you before, you could use polydoku because we still get that depressed polynomial. But synthetic division is a better route, and that's what I'm going to use in the notes. We have 1, negative 6, 11, negative 6. Those are my coefficients because I didn't have anything missing from my exponents up there. I'm going to bring down the first one. 1 times 1 is 1. Negative 6 plus 1 is negative 5. 1 times negative 5 is negative 5. 11 minus 5 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. This is important. If it really was a 0, it really was a solution, then I should always get 0 for my remainder. If you don't get 0, you've done something wrong, either setting it up wrong or solving it wrong. So what's so important here? I have to have 3 solutions. I only have 1. That's all I was allowed to pull from the graph. Well, what's important is that now I have this depressed polynomial left over. I have x squared, x, and no x. And I know how to solve something that looks like this. You have options. You can use quadratic formula, or you can use factoring. Because it has 3 terms, I can try and do a times c, or I could do quadratic formula. I'm going to try factoring because I think it's faster and I make less mistakes that way. So a times c equals 6. I also know that I can use factoring because remember when I looked at the graph, they all looked like integer solutions. They all looked like they'd be nice, pretty answers. That tells me that I can use factoring. If they looked like nasty decimals, then I wouldn't want to go with factoring. I'd want to just skip straight to quadratic formula. So a times c is 6, 1 and 6, 2 and 3. Factors of 6, and we want it to add to equal negative 5. That means I need to have either 2 pluses or 2 minuses. If I want it to add to be a negative, I want to go with 2 negatives. So negative 2 and negative 3. Toss it into my box. And we have x squared from the first term, 6 from the last term, and then negative 2x and negative 3x from my x. What comes out of the top? I can take an x, the bottom, -2, the left side, I can take x, the right side, I can take a -3. I'm going to set both of those equal to 0. Add 2 to both sides, and I get 2. Add 3 to both sides, and I get 3. So my 3 solutions, there's 1, and we proved it with division. Here's 2, and here's 3. You may not take all 3 from the graph and just do polynomial division for each of the 3. You must use other methods once you get down to something that you can either use quadratic formula or completing the square, factoring by grouping, sum or difference of cubes. Once you get it down to something like that, and once you've used polynomial division once, you may never go back to the original problem. You have to use the depressed polynomial to continue to solve. That's the only way to meet the standard. Number 2. Now, I know that I could use factoring by grouping to solve this, but since the directions said that we had to prove with division, I don't want to use factoring by grouping. Instead, I'm going to type the formula or the equation into my calculator. So x to the third plus x squared minus 16x minus 16. And graph it. And what I'm looking for is nice, pretty solutions. So I can see that I actually have my choice. It looks like all 3 of the roots are going to be nice, pretty solutions. So second calc, I'm just going to find one of them. Now notice I couldn't see where my x was, so I just pressed the left arrow until I could see it again. I'm going to try and find my left 0 here. Left side, right side, and I get that one of my zeros is at -4. And that's all I need is one of them. So -4. So I have 1, 1, -16, -16. Those are my coefficients. And bring down the first one. Multiply. Add. Multiply. Add. Multiply. Add. And you have to have 0 as an answer. So my depressed polynomial, it started with a cubed exponent, so x squared will be what the depressed polynomial starts with. And here's my depressed polynomial. Now, if you had used PolyDoku, you would get the same depressed polynomial, and you would use either quadratic formula or factoring to solve the rest of it. So quadratic formula or factoring would work because we saw all of the answers were nice, pretty answers. I used factoring on the previous one, so I'll use quadratic formula on this one. A is 1, B is -3, C is -4. X equals -b plus or minus the square root b squared minus 4ac all over 2a. We need to type in our discriminant, that's the part underneath the radical, into our calculator. So -3, make sure I put it in parentheses because it's negative, times 4 times 1, minus 4 times 1 times -4. And my discriminant, I get 25. The square root of 25 is 5. So 3 plus or minus 5 all over 2. Now, since I have no more radical in my answer, and I don't have any imaginary answers, I need to simplify this all the way through. That means that I need to separate this out into two separate answers. 3 plus 5 over 2 and 3 minus 5 over 2. I only need to do that if I have no radical and no I in my answer. 3 plus 5 is 8. 8 over 2 is 4. 3 minus 5 is negative 2. Negative 2 over 2 is negative 1. So there's two of my answers, and here is the third. Let's take a look at number 3. I'm going to go ahead and type it into my calculator. 3x to the third plus 10x squared minus x minus 12. Now, when I look at this one, I can see that I know I don't want to go after this 0 because it falls in between two numbers. I have an option with the 0 on the right or the 0 on the left because those look like they might go through nice, pretty integers. So second calc, option 2. And we're going to go with the left side. Notice it says x is at 0. Well, if I follow this down, that's why I'm not seeing it. It's off the screen somewhere over here. So if I'm going to find the left-hand 0, I'm going to need to move my cursor to the left. There it is. To the right would be above. And I get one of my zeros at negative 3. So 3, 10, negative 1, negative 12. 3 times negative 3 gives me negative 9. 10 plus negative 9 gives me 1. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 times negative 4 is 12. And negative 12 and 12 is 0. That's what I want. That's what I have to have. It started with a cube exponent, so x squared, x, and no x. This is what I need. I'm not going to try factoring with this because remember, one of my roots looked like a fraction, and I just want to make sure that it comes out nicely. So I'll use quadratic formula. So a is 3, b is 1, c is negative 4. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So typing in that discriminant into my calculator, I get 1 squared minus 4 times 3 times negative 4, and I get 49. 2 times 3 gives me 6. Now the square root of 49, that is something I know. It's 7. So I'm got rid of all of my radicals and I don't have I in my answer. So I need to split it off and have negative 1 plus 7 over 6 and negative 1 minus 7 over 6. Negative 1 plus 7 over 6 gives me 6 over 6, or 1. Negative 1 minus 7 over 6 gives me negative 8 over 6, which reduces to negative 4/3. That's the fraction one that I was seeing on my screen when I graphed it. So there's 2 of my solutions, and my third solution came up here. Number 4. Type that into your calculator. Now, each time we have had a degree of 2. If you have a degree that's greater than 2, it is possible that you will need to use your depressed polynomial and another root that you got from your calculator, from your graph. Like a degree of 4 or degree of 5, it's possible that you need to do your polynomial division multiple times. You might see that in the homework. So we're going to go ahead and graph this, find some zeros. Looks like the first one over here is a nice one, and the last one is a nice one. So this time I'll find the one on the right because I found the one on the left every other time. So the left side of my 0 waiting for my cursor to pop up. Oh, there it is. So left side, right side. It's a very steep line, so it just kind of went before and after. And we have 5 is one of my zeros. So that's what I'm going to use for my synthetic division. 5. So I'm not missing any exponents. So 2, -5, -28, and 15. Multiply 5 times 2 is 10. Add -5 and 10, we get 5. Multiply 5 times 5 gives me 25. -28 plus 25 gives me -3. Multiply -3 and 5 and I get -15. Add them together and I get 0. That's what I want. So x squared plus 5x and then a -3. I'm going to go ahead and use quadratic formula on this because I know it's guaranteed to work. A in this case is 2, B is 5, C is -3. So x equals -b plus or minus the square root b squared minus 4ac all over 2a. One of these days I'm going to write it just as fast as I say it or sing it. Type that discriminant into your calculator. So 5 in parentheses squared minus 4 times 2 times -3. And I get 49 again for my discriminant. X equals -5 plus or minus the square root of 49 all over 4. Square root of 49, we know that to be 7. -5 plus 7 and -5 minus 7 need to be split off because I got rid of all of my radicals and I don't have I. So -5 plus 7 over 4, -5 minus 7 over 4. -5 plus 7 gives me 2 over 4, which is 1/2. -5 minus 7 gives me -12 over 4, or -3. So there's 2 of my solutions. Here's the third solution.